Consider this number line. It goes backwards to minus infinity, and it goes forwards to infinity. So even if we only consider whole numbers, we can see that there are an infinite number of these whole numbers. Now consider just the part of the number line between 0 and 1. 1/2 is between 0 and 1. 1/3 is also between 0 and 1, as is a quarter, a fifth, a sixth, a seventh. 1/10,000th is also between 0 and 1, and so on. In fact, 1 over any integer at all is between 0 and 1. This tells us that there are an infinite number of numbers just between 0 and 1. And so far, of course, we've only considered fractions. We've seen that there are an infinite number of fractions between 0 and 1. And it shouldn't be too difficult to see that there would be an infinite number of fractions between any two whole numbers. Now consider that you have a 10-sided dice with faces numbered 0 to 9. You start with 0 point and then use the dice to produce the decimal expansion. So far you have rolled 247, 247, 247, giving you the number 0.247, 247, 247. Clearly this number so far has a recurrence pattern. Consider what it takes to continue the recurrence pattern. The next number you roll has to be a 2, and the probability of this is 1/10. However, to break the pattern, all you need to do is roll a number which is not a 2. The probability of this is 9/10. So you're more likely to break the pattern. Consider that the further your recurrence pattern goes, the more likely it is you'll break the pattern with the next roll than continue it. This should lead you to the conclusion that irrational numbers, those with no pattern, are more likely to be produced than those with a pattern. So irrational numbers are more likely. This means that if you throw a dart at the number line at random, it's more likely that you'll hit an irrational number. And yet we've already shown that there's an infinite number of rational numbers. If that doesn't blow your mind, I don't know what will.